Okay, guys. 12.6, probability and decision making. So still, again, as always, looking at probability. I say as always in this unit 12. Okay, we've done a lot with probability. This is probability and decision making. So looking at how probability can play into deciding if a set of events is fair or not fair, those type of things. Okay, so not just you as a little kid saying, "Hey, that's not fair," but officially, what makes something fair versus unfair. So, okay, beginning example here. Your friend offers to play the following game with you. If the product of the roll of two number cubes is 10 or less, I win. If not, you win. Okay? So question A, if you were to play the game many times, what percent of the games would you expect to win? Now, we created this chart earlier in the chapter, didn't we? Okay, I'm providing it for you here, saving us a little bit of work today. But you understand what this chart is showing, right? It's showing like if you roll a 1 on the first die, you get a 1 on the second die. You get a 1 and a 2, a 1 and a 3, 1 and a 4, so on and so forth. You get a 2 and a 1. This shows all the different combinations of dice, results you could get. So, thoughts?
55%.
Are you just randomly making up numbers?
No. No, hear me out. Right? You take, so obviously to win, right, you have to have a number 10, right? 10 or less, right? So
6 times 6 gives us how many there are? 36, right?
we know 5 plus 5 is 10, right? Oh wait, product? Yeah. So never mind.
Wait, what's the question?
Okay, so.
Was I right?
Wait, what's
No.
the question?
There's two combinations.
Play the game many times. What percent of games do you expect to win?
Okay, now keep in mind, we've got your friend offers to play the game. What's your friend do? If the product of the roll of two number cubes is 10 or more. If the product of the roll of two number cubes is 10 or less, I win. Who's the I win in that? That is your friend. If not, you win. That is you. Okay? Us. Whatever. So we need to, it's not just a guessing game, folks. Find the math. Okay, do the math here. So if that means what's best is, going through and writing down, or at least, evaluating what your products are. What's product mean? We're multiplying. So if I look at the first column, 1 times 1 is?
1.
1. 2 times 1?
2.
3 times 1?
3.
So on and so forth. So those products are 1, 2, 3, 4, 5, 6. In the second column, 1 times 2 is? 2. 2 times 2? 3 times 2? 4 times 2? 5 times 2? 6 times 2. So 2, 4, 6, 8, 10, 12. This next column, are you figuring out the pattern? This is going to be multiples of 3. 1 times 3. 2 times 3. 9, 12, 15, and 6 times 3 is 18. Okay, my 4 column. 1 times 4 is 4. 2 times 4, 8. 3 times 4, 12. 16, 20, 24. Okay, 5s. 1 times 5 is 5. 2 5s, 10, 15, 20, 25, and 30. Not that you'd have to write these all out, but as we look at questions, it's going to help us see them better. And 6s. 1 6, 2 6,
12, 18, 24, 30, 36.
Okay, so 6, 12, 18, 24, 30, 36. Now, with that in mind, okay, let's look at, so the original plan said the probability, and it says if the product is 10 or less. So let's look at product of 10 or less. What's the product when the product is 10 or less? What are we looking at here?
10 or less.
Ready to memorize 10 or less.
You gotta count.
Okay.
3, 6, 7. Count.
6, 7, 8, 9, 10. Do I conclude 10?
Yes.
11, 12, 13, 14, 15, 16, 17, 18, 19 if we're talking 10 or less, correct?
Yes.
And that's 19 out of what?
36.
Okay, that's 19 out of 36. And that is who?
If they win.
Okay, that is
You losing.
your friend.
Yeah.
Fair enough?
Fair.
Now, if not, you win. When do you win?
The 36 minus 19.
Okay, and I'm going to write it here as when the product, you guys are probably going to say more than 10. I'm going to say when the product is not 10 or less, because it's at the opposite of it then.
Yes.
Okay. Now, Logan used the idea of, he just said 36 minus 19, because if there's 19 that are more than or less than 10,
It's got to be 17 that one.
the other 17 are going to be not 10 or less, so more than 10. So 17 out of 36. And this is
You.
you. Now, if you were to play the game many times, what percent of the games would you expect to win?
47%.
Okay. You're going to expect to win 17 out of 36, which as a decimal is 0.472 repeating, which as a percent is 47.2%. Okay. With that in mind, B. Is the game fair? Should you take the offer to play the game?
No, your odds of winning are not high. His odds of winning are higher than yours.
Okay. Your friend has a greater probability of winning?
You're more likely to lose.
Okay. You have how many ways to win?
17,
17. Your friend has
19.
19. Your friend has more ways to win than you. All these different things that we've said are good, but the game is not fair. Okay, if the game is fair, there's going to be equal chances for both of you. Okay, we'll talk about how that relates to expected value here in a moment, but on my paper I have you only have 17 ways to win, but your friend has 19. However you want to express it. No, you have 17 ways to win. But your friend
Has 19.
has 19. Your friend was hoping they could sucker you in and you'd fall for it and want to play, right?
That's right. But T. Gibby over here knows better.
No our statistics.
That's right.
Yeah. Now, okay, C. Suggest a way to change the game from fair to unfair, or vice versa, since, we don't officially know, but from unfair to fair, while still using the product of the two number cubes. What'd you say? Let's talk about that. How many 10s are there?
2.
There's 2. What's the first thought that comes to mind?
Just put the 2 10s in here.
Okay. Yeah. So the first thought that comes to mind is that, okay, well, instead of it being 10 or less, make it
10 or more.
right. Okay. But
It's just not include 10.
what happens then? if you take these two 10s and you move them away from your friends group to your group, is it fair now?
No, it's still unfair.
I mean, for me,
I say now it's still unfair, but in the other way. Okay, so we need a different plan because the goal is to make it fair for both of you, whether you like it or not.
let's just not count 10. 10 doesn't count.
Okay, she says just don't count 10.
I like it.
Okay, so what happens when we do get a product of 10?
You just
Nothing.
negate it.
Okay,
Omit.
it doesn't count for everybody. It's omitted. Reroll.
I like
Okay.
that.
So that's kind of the idea that is on my paper. Your friend wins when the product is less than 10. You win when the product is greater than 10. If a product of 10 is rolled, re-roll the dice. Okay? So however you want to express that. But I'm going to say, I'm going to shorten it a little bit. Make the groups less than 10 and more than 10. If 10 is rolled, it is a re-roll. It doesn't count. It's omitted. Whatever variation of that you said. Okay? Yes?
I have a final idea.
Oh, no.
We all make our own probability type of game.
Oh, no. Okay.
Well,
Stay on the... Okay, we're going to talk 12-6 right now. You have a final exam coming up, so...
Hear me out. Just give us A's.
Okay, do we have what we need here?
See?
Yes, that was part C.
Yes, we do.
Okay,
Yeah.
so let's move on and let's talk about, in this next section, we're really just kind of talking about ways to make something fair. Okay, kind of goes back to what we were doing in Unit 11 with making things random and fair. Sadie, Tamira, River, Victor, and Jay are candidates to represent their school at an event. How can you use random integers to select 2 students from the 5 candidates so that each one is equally likely to be selected?
Okay, so hear me out. Right. I don't know.
Let me read it first.
Quick piece of vocab. What do we mean by integers?
Numbers.
Okay, numbers, those are basically, I always call them positive or negative whole numbers, is what I say. Because when I say whole numbers, you guys know whole numbers, right? Whole numbers are only positive. Integers include positive or negative. So we want to use random integers to select 2 students from the 5 candidates so that each one is likely to be selected.
Should we find that in CR?
Now, just come up with a process here, a description. We're not actually going to mathematically do anything here.
Oh.
Start fighting them. Let them duke it out.
Oh, we're just trying to find something like
Pick a name out of a bowl.
Okay?
Yeah, I like that.
Okay.
Equally random.
Okay? Change it up, though, because they're asking us not to use names. They're asking us to use random integers.
Okay, so
Numbers
assign
in the bowl.
each person a number, but then use Jack's bowl.
Okay? So, assign each person a number. And then the situation is put 5 numbers in a bowl and draw a number from the bowl.
Yeah.
Okay? Could that work?
Yes.
Yes. Okay? And I think the idea there is just that if you don't necessarily know what number is who, it's a little more random than looking at names. Okay? My notes assign a number to each student, 1 through 5. And then I went with the idea of use a random number generator.
There you go.
Like on our calculator, there is ways on calculators where you can ask it to give you a random number 1 through 5. Okay. And so with that in mind, you could generate a random integer that way. Okay. That's not really a whole lot different than drawing a piece of paper out of a hat, is it? Okay, but it's the same, same idea. So that's all we're asking to do here. So assign a number 1 through 5 to each student. And then, however, whether you want to pick a number out of a hat, out of a bowl, use a random number generator, but somehow pick a random number 1 through 5. So mine is listed as, I'm going to go ahead and use a random number generator. So pick a number 1 through 5. Okay. And again, there's not one right answer here, right? If you said pick a random number out of a bowl or something, that's fine too. Okay. Another scenario. Your trainer creates training programs for you. How could you use index cards to randomly choose the following? Strength training 1 day per week, cardio training 2 days per week with no consecutive days, and swimming 1 day per week.
Kind of like the same thing we just did.
So you could put on one card the strength training, cardio, 2 cards, swimming, and 1 card the next one.
Okay.
And then if you get cardio, if you get both cardios like one after another, just redraw.
Okay. And so one option, put each of the different types of trainings on a card. And there's, since we're doing cardio train twice, there's going to be 2. Draw a card. It's a redraw if you get cardio 2 days in a row.
Yeah.
Okay. Now, how do we decide which days of the week we're doing this?
Whatever.
Whenever you feel like it.
I mean, are we doing something, because it is swimming 1 day per week, cardio 2 days per week, and strength training 1 day per week.
Weekdays only.
Yeah, weekdays.
Weekdays only? I still got 1 extra day.
Leaving
That's
Monday
your
as a
rest
rest day.
That's
Okay.
actually a good thing for the body. Just let it
You need a
rest.
rest day.
Okay. So if you just have set days that you use it, then it's just a matter of picking the order, right?
Yep.
Okay. Other thoughts?
Almost gonna tell you, I don't think there is. I think we're perfect on the dot. Both times.
I had an idea first hour that was putting days of the week on a card, or days of the weeks on cards, putting the trainings on cards, and then,
Makes sense.
yeah, you're picking a day of the week, you're picking a card, a training card, and putting them together.
Yeah,
Okay.
we're talking about mine really correct. Thank you.
So if you put both on cards, that was an idea first hour I had that sounded good, where days of the week, trainings, pick one, and as long as you don't get cardio 2 consecutive days, then we're good there. Okay. And then my book option isn't either of those, because my book option was, instead of putting these on cards, it was picking days of the week on cards. So if you just put, so kind of the reverse of what you guys said. If we just put days of the week on card, and I say, okay, I'm going to pick a day for strength training. Okay, here's my day for strength training. Okay, I'm going to pick a day for cardio. Draw 2 cardio cards, and then a day for swimming. Okay? There's options, right? Okay, there are options. You're doing some kind of combo here, putting this information on, putting them on cards and drawing. Kind of like assigning numbers. Okay? So, in all cases, it's redraw if you get cardio consecutive. But, okay, so what did you guys say? You guys said Write each training on an index card. And how did we say that? Write each training on index card and
Randomly draw.
Draw at random.
draw it randomly.
With redrawing if you get cardio today.
Yeah. And cardio is just always, I don't even know if I want to write that down, but it's always going to be a redraw if you get 2 consecutive days. The other options, another option would be write each day of the week on a card and draw randomly. And if you want to write it out, you could write that. You could also put both on cards and draw them. Yes. Okay. So I could see either or. It is a long lesson, yeah. And we'll get maybe half of it done today. I don't even know that we'll get halfway through today. Okay. Next page when you're ready.
I don't know if I'm ready to be ready.
Okay. So, looking a little more officially about determining if something is fair or unfair. So, as we look at this next example, Thedo places 3 cards in a hat, labeled 1, 2, and 3, and challenges Helena to a game. Thedo says, if you draw a number greater than 2, you earn 2 points. Otherwise, I earn 2 points. Is this game fair or unfair? And if it is unfair, which player has the advantage?
Unfair. They has the advantage because he gets 2 numbers and Sherman gets 1.
Okay. In this scenario, we can clearly see that Thedo has a better probability of winning, yes?
So it's unfair.
Now, what we have to consider, though, point-wise. The points are the same, though, aren't they?
Yeah.
Okay? So either way, it's a 2-point, so it's not a difference in points. Now, I want to show that, and you guys are seeing it, that it is unfair, and I'm agreeing. Okay? I want to show that in terms of expected value and how that can play into things, because when we get more information that makes it not quite so obvious, I want to be able to use expected value. So, what is Thedo doing? Thedo can either, okay, essentially win 2 points or lose 2 points, right? Lose 2 points is in those 2 points going to Helena. So Thedo either wins 2 points or loses 2 points. And you could say does not win 2 points. Okay. Now, what is the probability that Thedo's going to earn 2 points?
2/3.
Because when does Thedo get 2 points?
When she draws a number, or when she draws a number less than 2.
Okay. Yeah, and I guess I should have done the other one first. Because if you draw a number greater than 2, who's you?
Helena.
Helena. So that would be a -2 to Thedo, right? So if you draw a number greater than 2, what's a number greater than 2?
3.
3. So the probability of drawing a 3 means he's gonna have 2 points against him. What's the probability of drawing a 3?
1/3.
A 3 out of 3 numbers is 1/3. Now, otherwise, I earn 2 points. When does he earn 2 points?
2. 1 or 2.
That's when you draw a 1 or a 2. What's the probability of drawing a 1 or a 2?
2.
2/3. Okay? And so, and I set this up in terms of in relation to points, and I picked theta, since theta was the one setting this up. But expected value. We've been talking about expected value the past 2 days, right? It says you do the outcome times the probability that outcome will happen. Plus, same thing. So the first outcome was him getting positive 2 points, and the probability that could happen? 2/3. Plus, the second outcome is he could have basically 2 points counting against him, right? Not that he necessarily loses 2 points, but he has 2 points counting against him. And what's the probability that that can happen? 1/3. Okay. Find this expected value with me. 2 times 2/3. What is 2 as a fraction? 2 over 1 times 2 over 3 is 4 over 3. Plus negative 2 times 1/3. Well, that's negative 2 over 1 times 1 over 3 is negative 2/3. 4/3 plus negative 2/3 is 2/3. Okay, that expected value says that CO has an expected value of 2/3. If this is truly a fair game, theta plane and Helena plane, they should be equal, which means the expected value would be 0. Okay? If this is a fair game, the expected value is 0, and that's the point I'm trying to make here.
And this is unfair.
Yeah, if a game is considered fair, the expected value is 0, because they would have equally likely chances. Here, while the points are the same, the probability is not the same, is it?
No.
So this is, the question was fair, unfair, which player has the advantage? This is, as we talked about, unfair. And the advantage is to theta. Okay, and understanding that that expected value of 2/3 factors into that. Okay. Now, typical kids, Helena's going to propose a change to the scoring of the game. Because it's not fair to her, is it? So, she's going to propose a change to the scoring of the game. She says, if I draw a number greater than 2, I get, supposed to say 2 points right there. Okay, sorry, that's left out. So this is Helena saying, if I draw a number greater than 2, I get 2 points. Otherwise, you get 1 point. Is the game fair or unfair? If it's unfair, which player has the advantage? Now, I did this in the same standpoint as I looked from Theto's point of view again when I did this. Okay, and you could look at it either way. At least I think I did, if I recall correctly. Yeah. Okay, so if we look, I'm going to look from Theto's viewpoint again, just to try and be consistent. I don't know, maybe I should do it the other way. Should I try it from Helena's viewpoint?
Full send. You won't.
Okay. So, what are we doing here? Helena says, if I draw a number greater than 2, I get 2 points. What would that be to Theto?
Minus.
That would be a -2 to Theto. And when is that a -2?
2/3 of the time.
A number greater than 2, which is a 3. And the probability of drawing a 3 is a 1/3. Okay?
So we just
Otherwise,
write this down.
yeah, we're gonna put it all together here in a moment. Otherwise, you get 1 point. Who's you? Theto.
They do.
So Theto is getting 1 point. That's a +1. When is Theto getting 1 point? Okay.
If it's 1 or 2.
If it's not greater than 2. So that means if it is 1 and 2, which is how many? That's 2/3 of a chance. Now, this one's not quite so obvious, is it? Last time it was obvious because it was equal points, +2, -2, but the probabilities weren't equal. Here, we have different points and different probabilities. And so this is where your expected value is going to be helpful. So think expected value. What could Theto do? Theto could score -2 points, and what's the chance he scores -2 points? Or he loses 2 points? 1/3. Plus, what's the other thing he could do? He could score 1 point, and he has a probability of 2/3. Well, -2 times 1/3. It's -2/1 times 1/3, which is -2/3, plus 1 times 2/3 is 2/3. -2/3 plus 2/3 is 0. What just happened?
The game is fair.
Okay. The sides balance out, don't they? The fact that, okay, Theto could lose 2 points, but he only has a 1/3 chance of losing 2 points, versus Theto could earn a point. It's only 1 point, but he has a 2/3 chance of doing that. It all equals out. Okay? So this is
Fair.
fair, and my proof is the expected value is 0. Okay? And that's why we talk about the expected value. And I don't know, you guys, did you see this one from the beginning that you could tell it was going to be fair? Or just the last one's unfair, so we know this one's going to be fair? Maybe that was the trick we went with. But I want you to see that there's a reason for the expected value trick here. Okay. Questions? Have I made that make sense a little bit? Because I know this is not the easiest stuff sometimes. At least me trying to explain it is not. Okay. Shall we talk about Justice and Tamika then?
We don't have to.
Yeah, we will. Okay. So, continuing on. Justice and Tamika use the same 3 cards but change the game. In each round, a player draws a card and replaces it. And then the other player draws. The differences between the 2 cards are used to score each round. Order matters, so the difference can be negative. Is each game fair?
Yes. Because the last one card I was.
So we're alternating here. Okay, well, let's do some math and actually figure out. Okay, so are we grasping? There's the same 3 cards, so what cards are we using?
3,
Same 3 cards, so we're using
2, 3.
1, 2, 3, right? A player draws a card, replaces it, then the other player draws the card. The difference between the 2 cards are used to score each round. Order matters, so the difference can be negative. Okay, so A. If the difference between the first and second cards is 2, Justice gets a point. Otherwise, Tamika gets a point. Well, what do we have to figure out here? How often can you get a 2, right? And I don't have a fancy way to do this other than I wrote out all the combinations. Okay, which there's not a bunch, but I wrote out the options. It's like, okay, what's the first card we could draw?
1 and 1.
A 1. If we draw a 1 first, then what's the second card I could draw?
1.
You could draw a 1, right? And if you draw a 1 and then a 1, it's the difference between the cards that's going to matter here. And what is 1 minus 1?
0.
0. Okay? What else could I do? If I drew 1 the first time, I could
Draw 2.
draw 2 the second time. And 1 minus 2 is -1. If I drew 1 the first time, I could also draw a 3. And 1 minus 3 is negative 2. Okay? What if I draw 1 again? Are there any other options with 1?
You would get a -3.
Okay. There's no other options with 1. You could draw a 1, 2, or 3 as the second card. So, what else could I draw first?
2.
What if I draw 2 first?
2. You could draw 1.
I could draw 1. 2 minus 1 is 1. If I draw 2 first, I could also draw a 2. 2 minus 2 is
0.
0. Or I could draw 2 first and a 3. 2 minus 3 is negative 1. What's my other set of options? I could draw a 3 first. If I draw 3 first, I could draw 1. 3 minus 1 is 2. I could draw 3 first and a 2 second. 3 minus 2 is 1. Or I could draw 3 and a 3, and 3 minus 3 is 0. Okay. If the difference between the first and second cards is 2, Justice gets a point. So what do you see?
There's only one.
Only one chance. He was
There's only one chance Justice gets a point. Otherwise, Tamika gets a point.
Does -2 nothing?
What?
Does -2?
It does not, because it's basically if the difference between the first and second card is 2, and it did say order matters, so difference can be negative. So there is a difference between +2 and -2.
So 1.
Okay, so the probability that Justice gets a point is 1/9. Otherwise, Tamika gets a point. Probability that she gets a point 8/9. Do I even have to do the math here?
So it's unfair. No.
Yeah, this one's unfair because it's both 1 point each way, right? But the probability is nowhere near the same. Okay, so there are more ways for Tamika to score points.
So Tamika has the advantage.
Yes. So, is the game fair? No. More ways for Tamika to score a point. Okay. B. Do I have time? We'll see. I think so. They take turns drawing first. Each round, the first player to draw subtracts the second player's number from her own, and the result is added to her total score. So this goes back to the question, is each game fair? So this time, they take turns drawing first. Each round, the first player to draw subtracts the second player's number from her own, and the result is added to her total score. Is that fair?
Yes.
Why, yes.
Because you're not looking for a certain number, it's just whatever. It's all random. So each card has a 1/9 chance of being pulled, and then it's an equal chance for you to get whatever points you get.
Basically, they could each get each of these options here, couldn't they? Because they take turns drawing first. Okay. Each round, the player to draw subtracts the second player's number from her own. The results add to her total score. So basically, these are the options again, but the scoring is you get whatever you get. Okay. Everyone has the same options to draw all those cards. Okay. So this one, since both players can earn all the same scores, the expected value would be 0 and the game is fair. Okay. So since each player can earn the same score, Each player can earn the same scores. The expected value is 0. And game is fair. Okay. Tomorrow, we will start off talking about Rashawn. And then continuing along. 12:5, make sure you get it done. 12:6, I'll get out there later.